Let's review some of the stuff that we tried to learn last week. So we're trying to look at describing relationships, how closely are two variables associated with each other, and you've got the response variable and the explanatory variable, all that stuff, and we do that using a least squares regression line. Now this is from NFL.com, and check it out, statistics right here. So this is all about quarterback statistics. Now, football has changed from the time that I played in high school, and most everyone has adopted this West Coast offense in the National Football League, which is basically, it's a passing game. It's all about getting yards by passing. So here's the quarterback rating right there. It's a fairly fancy formula to figure out what that rating is. But I just want to look at the amount of times the quarterback passes the ball versus how many yards they get. Are they related? I have a feeling they are related, but let's see how good that data is. Here we are with the attempts. How many times does the quarterback throw the ball, okay, so far during this season? And now that's just from the last 2 weeks. And then you've got over here, where is it? Oh, yards gained, right here. So my response variable is going to be yards gained, and my explanatory variable is going to be, well, the yards gained is explained by how many times a quarterback throws the ball. Okay, so I'm going to do some work with that on my calculator. So I did some work, and here's the results. Now I want to let you know that there were 38 quarterbacks listed on that website, and I put all those numbers in there. You just can't see them. And remember, we got the explanatory variable, which explains the response variable out here. Number of passes explains how many yards we get total for all those passes. Now I think that there's some sort of a relationship between these two, and so I graph them and see what it looks like. And by using that stat plot that we know how to do, it looks like this. So it looks like there is, if I drew a line through there, it looks like there is a somewhat of a linear pattern, and as the numbers go up, there's a little bit more variation in here. We're a little bit further away from the line out in this area. For instance, this looks like there's a pretty good outcome as far as lots of yards and not as many passes as these guys out here. So there's that. Let's take a look at what other information we can look at. Well, we can get the actual best fit line, which we don't have to figure out how to do. We get the calculator to do that for us. And here is the slope. Here's the y-intercept. And here are two important numbers. So you got the this R right here is the correlation, which means how good is our data? Well, our data is pretty good. Anything when we get up into that 0.9%, actually it's not really a percent, but that 0.9 area, we say yes, there's a pretty good association between the explanatory variable and the response variable. So our data is pretty decent. That's what we're really after. How good is our data? Well, our data is that good. And then we say, well, what about the variation? And this is called the coefficient of determination, this R squared. Coefficient of determination means that now we do have a percentage. This is 77% of the variation is accounted for by our least squares regression line. Wow, that sounds pretty smart. Let me say it again. 77% of the variation in our data is accounted for by our least squares regression line. And that's a good phrase to remember, and I'll write that down in a second. But also we want to look at, here's the equation line. I put it into y equals, our regular old plot of line, and here it is. Here's the slope, there's the y-intercept, and then we plot that line, and it looks like this, kind of like what I drew, but that's the exact line that we want, right through there. And what they might say, well, what does this mean? and it's really important for us to understand the slope, which is the slope kind of tells us right here that for every pass that we make, we can expect our total yardage to go up by 6.5. And that's pretty good return on investment as far as football is concerned, 6.5 yards per pass. But that's overall. That's for, say, 108 passes. You can assume that this is going to be about what our return is, which is probably why so many football teams go with what they call, I guess, the West Coast offense, which is a passing offense. So, there's that. This is a very good phrase to remember. So in this case, 77% of the variation in our data is accounted for by our least squares regression line. So this is a little bit important. Right here, this least squares regression line, this is really just a prediction of what we're going to get. Based on, it's kind of nice that we have an equation for this, and we can say, well, if we plug in a number for this x, we can kind of predict how many total yards we would get if we threw this many passes. Well, here's an actual situation. This quarterback threw 108 passes, and he ended up with 764 yards. Okay, let's take a look at how that matches up with our prediction. How do we do that? Take the 108, plug it in for x, crank out this number, and compare it to this number. And we're going to see how far we are from our prediction. The actual value versus our predicted value for 108 passes. That is called a residual. Let me do that real quick. So in this case, our predicted value would be 749. We actually did get 764, so we're not that far off. How far off are we? Well, let's subtract them. And there we go. Right here, I subtracted these two, and we are above the line by about 14.87 yards, which is pretty close to what our line said. So that's the residual, how far we are off. Anyway, I'm going to stop right there. I'm not going to do the residual plot part because I think this covers a lot of material, and I will see you tomorrow, first thing in the morning. Okay, hope you're having a great weekend. Bye.